I'm Jun Kato. I am the senior researcher at National Institute of Advanced Industrial Science and Technology. And I also serve as the technical advisor at Arch, which is a Japanese animation production company. And within both positions, I do human-computer interaction research, which is about studying creative activities of people, including programming, video authoring, storyboarding, making animations, all of these things. And then I help them through building and deploying creativity support tools. HCI stands for Human-Computer Interaction, which is my research area in general sense. And if you look for this terminology on the web, you find descriptions like this is a research in the design and use of computer technologies, deeply related. I think it's deeply related to the humanities in a sense that it's not only about the technologies, but also about human beings, because, it's really about mediating the relationship between humans and computers, which is especially important in these days where, everybody says artificial intelligence and, massive amount of information about day-to-day advances in AI technologies are kind of overwhelming people. But I think it's really important to think of how we can utilize computers to benefit human beings in a broader sense. And so this is really the research area called HCI, or human-computer interaction. And this figure is taken from Antti Ostolovic's paper back in 2016, which is not too old. It's still like 7 years ago. I remember the talk at the conference. And they define HCA research as problem solving. So it's really about, there is this human use of computing on the left side. And if we find, as a researcher, if we find something that we can improve, we define the research problem and do a kind of empirical study, like interviewing people, and then kind of come up with the kind of solutions, technical solutions, or social technical solutions, and build a kind of prototype systems, test it with people, the real people, and then see how that solution works well or not. And it's really this cumulative cycles of defining research problems and solving these through our novel technologies that we develop with computers. And what this field really attracts me is its importance in the post-AI era, I would say. I think you have heard of the term AI, artificial intelligence. Like these days, people are using ChatGPT, stable diffusions. There are many kinds of AI-based technologies that can help our daily life or work life. And when we say human-centered AI, it's about designing AI in the human-centered way that benefits people. And when we say augmented human, it's really about amplifying people's intelligence or amplifying humans' abilities. So let's say we have ChatGPT. It certainly enhances our intellectual ability, right? It tells us many things, and with help of these AI technologies, we can do much more intellectually. But also, interesting thing is that there are many kind of computer-supported hardware technologies. For example, there are people with disabilities, but we can develop systems that help them. And interesting thing is that it's not only for making minus to the zero, but also making one to many or much more than that, which means that these days, when we go to Olympic, there are people running, right? And there are also Paralympians. Paralympians can run. And interesting thing is that Paralympians can run faster than human beings, because of the specially designed, how to say, it's a gisoku in Japanese, but it's not a leg, but it works as a leg, and it works better than the human legs in a sense that it allows people to run faster. So it's really possible to develop something that enhances our cognitive and physical abilities these days with help of the computers. So it's kind of augmented human, the idea of augmented human. But then what attracts me or what puzzles me is that, okay, so there are so many people who do better than past people in a sense that they are enhanced. What should we do as a human beings? Because AIs really automate many things, and now we can focus on something interesting, but it also means that people needs to or forced to focus on something interesting that cannot be done by AI, because AI is in many cases cheaper, right? Or more affordable. Or let's say if we want to hire 10 people, it costs 10 times more expensive. But when we want to run the programs 10 times, it doesn't cost much more than that, right? So it's really difficult problem to think of how human beings should behave in the age of post-AI era. And here comes this, research area of human-computer interaction, where we really think of how people can live happily, how we can enjoy our well-beings, and how we can enhance those people's well-beings with help of the technologies, not by forcing them to, do something, but rather leveraging their abilities or leveraging their creativity in their everyday life, which is what we call mini creativity. So this is sort of my perspective of my research studies. This slide also shows my kind of research style or a preference on how to convey the research. As I said, human-computer interaction is really about thinking of the relationship between humans and computers and helping them improve the relationship through the novel technologies. But I really like to work closely with the end users or creators or programmers. So from the left side, I have developed many programming environments and tested it with the real programmers, or in some cases, primary school students by holding kind of workshops. And in the middle, you see systems to enhance creativity of musicians or video authors to create music videos. Or in some cases, it also allows them to create a novel kind of media format called lyric apps that we have proposed several years ago. Or on the right side, you see a kind of digital tool that allows anime directors to draw econte or storyboards in English. So all of these are my concrete projects that I have worked on. I have really worked as a toolsmith for these creators or programmers, making creativity support tools, toolkits, program environments for these creators or programmers. So this is kind of brief overview of my research and who I am. It's really difficult to answer because when I was a young kid, there was no term like STEM, People say, okay, you like humanities or you like science. The kind of, vague distinguishment was already there, but we didn't think of STEM as established concept at the time. So first of all, I was a kid who likes to read books, many books, but not necessarily science or natural science or those kind of things, but rather like storytelling, like novels. But interestingly, at some point, my parents bought me a computer. I think the first one was Apple Macintosh. And then I moved to a Windows-based PC. But anyway, when I first used my Macintosh, it was only a local computer, kind of standalone one. I think that was when I was a primary school student at the age of, I don't know, less than 10, I guess. But then when I entered the junior high school, I bought my own personal computer, a Windows-based personal computer, with my, in Japan, there is a tradition of otoshidama that, siblings or, parents or some people give me money at the beginning of the year. So I used that to buy my personal computer. And that was connected to the internet. And that was really eye-opening to me because then I could actually connect to many people, not only at the same age as myself, but elder people. And I could make a website at the time. by writing the source code of the web page. I really liked designing something at the time, designing websites or taking photos. I like those kind of creative stuff, doing creative stuff randomly. I think that was a sort of STEM related interest in the young age. And then I gradually moved to do programming by myself. I made a music player software, and I published it on the website. And there were a sort of community of people who were using the software. I really liked that atmosphere of feeling people are actually using my software. That was really nice. Yeah, long story short, I think the experience of making a music player, it is somehow connected to my interest in HCI, because the music player that I developed, there is a website. The last update date is 2007. It's already 16 years old. Yeah, this is a music player, and it has many sort of skins that can change the appearance of the music player. Like, there is this animation character, but here is the play button, stop button, pause button. All these user interfaces were developed by, I think this is made by myself, but I kind of open sourced the definition of these skin files. And there are many fan-made skins available online. And so here I was kind of supporting the creativity of the skin authors of this music player, right? So I think that was my first experience as somebody who makes a tool that allows people to flourish their creativity. It's really like, 2005, 2003, about 20 years ago, but I was already kind of attached to this idea of making something for people who can do cool things. I mean, I cannot draw illustrations like this. This is an illustration drawn by my friend, and I really like people making cool stuff. And I kind of feel proud of making a tool that allows them to do that. When I was thinking of entering the universities, they sometimes had a design department that I was interested in. And I was also interested in the studies of humanities. So I was even thinking of going to a school of laws. But finally, I decided to go to the University of Tokyo, where it's interesting that at the University of Tokyo, people don't need to decide their major at the time of their entering the university. They can kind of delay it until the end of the second year of the undergrad. I like that idea. And then finally, I decided to go to the computer science department, but that's really, 2 years or 3 years after I entered the university. So when I entered the university, I was surprised to see the range of the courses that they have. I entered the science-related department, which is called Rika Nirui, where there are many people who are interested in biology. But anyway, Rika Nirui course allowed me to take various kinds of courses, not only science, but also humanities. And one of the most interesting courses was led by a journalist called Tachibana Takashi. If you look into his publications, it's really diverse, like, from political topics to economic topics to scientific topics to, everything, like universe or software or brain-computer interfaces, or robots, or, everything. He was interested in everything that the weekend came up with. I mean, and he's a journalist, so he can interview as many people as he wants. And joining his seminar was really epoch-making for me. And that seminar was not only about listening to what he says, but rather he was really a kind of person who is really enjoying his freedom. So he just leave us some topics, and we are kind of looking for topics that inspires us the most. And then we go to the laboratories, and like, we were at the time interested in the frontiers of biological science, and we could go to the University of Tokyo, but also other organizations, and listen to kind of top-notch researchers discussing what it is about RNA, or it's sometimes it's also about the fusion science, or there are lots of these interesting topics going on in this seminar. And among them, I was responsible for leading this particular project that was about connecting the brain-machine interface science with the world of animations. As you know, Japan is really famous for making these kind of cool animation, beautiful animations, right? So, okay, now we have the connection with Takashi Tachibana, who is really famous in Japan. So how about going to this kind of discussion session and help Takashi say something interesting, and also listening to all these anime directors saying something interesting. We were accompanied, Takashi accompanied our students with his interviews, and we were really that was really intriguing. And also we kind of organized this kind of a project at university festival kind of thing. So all of these things are related to brain-machine interface, but also it's also related to the humanities studies, right? Because it's also about the philosophy, or how we should go on with these kind of technologies. So these are all my university life that helps me build the kind of broad idea of what science is, what humanities is, and how we connect these with these engineering research. For me, that's part of the creativity support research, in a sense that programming experience is about providing programmers a novel kind of programming experience, literally, by providing tools to create programs. Now you see the screenshot of the system that I built, and you already noticed that there is this Lego Mindstorm-based robot in this photo, raising the white flag. But on the right side, you see this pose library where there are many photos of robots, right? So this is a novel programming experience that I provided to the programmers through these novel integration of photos into the program environments. Usually, when programmers write code for robots or for detecting human posture, they need to write a text-based source code, like if pose equals something, do something, or robot.set pose, pose data. And all these are done in either text-based or symbolic ways. But what I thought is, okay, nowadays programs are running everywhere, ubiquitous. There were robots. There were also cameras. And cameras can detect human postures, and robots allows us to delegate physical tasks to computers. And how should we design this programming experience with these real world things? That's a kind of broad question. And now I noticed that at the time I noticed that all these available software or programming environments only provided either this kind of text-based programming experience or a kind of symbolic programming experience. That's difficult to explain, but imagine there were multiple nodes connected to each other, and all of these relationships between nodes define how robots should move or behave. But all these things are either text-based or symbolic representations. But consider, if we want to point to this specific posture, we cannot name it, right? But if we want to write text-based programs, we need to name it somehow. And we found that in many cases, people assign like dates or times to the file name or the variable name. In a simple case, we can say, okay, this posture data can be referred to as a human with right hand up, or a human who is running, or a human who is walking. But there are so many possibilities of these kind of statuses in the real world, which is really difficult to be represented by the text-based or symbolic-based programs or source code. So the simple idea is to integrate these kind of photos into the code editor and allow people to, read the source code as integration of photos and text-based code, which is way easier than some sort of random text-based representations or some sort of array of the numerical values. Photos is really helpful for human beings. And when this program runs, it actually loads numerical data. So for the computer, the photo doesn't mean anything, but the environment kind of manages the relationship between these photos and the numerical values. And people can only concentrate on these graphical representations, whereas computers only need to focus on the numerical values or the representations that are suitable for themselves. Here, this programming experience is really useful for programmers because people can understand what's happening by just looking at the source code. And this is evident by the workshop that I held at Nihon Kagaku Miraikan, which is a famous Japanese national scientific museum. There was a workshop held with primary school students who were not necessarily knowledgeable of doing programming, but they could actually take photos randomly, but they can modify the definition of the programs and enjoy editing the programs themselves. So this is kind of concrete example of what novel programming experience is. But there are many other ideas like utilizing the pressure-sensitive keyboard or having this kind of timeline interface in the program environment, or allowing people to edit the program while it's running, or even allowing designers to create this kind of robotic things that adds mobility to everyday things like alarm clocks, or this kind of crazy ideas can be supported by introducing novel programming tools and enabling novel programming experiences. AIST is actually not an industry job because it's a national research institute, but it's not the university. So I think you interviewed a very interesting person in a sense that it's really in between academia and industry. So universities are, of course, academic jobs, right? University professors. They do lectures to the students, but also they spend time doing research. And then there are industry jobs where they make direct impact in the society. And also there are researcher jobs there. And we are really in between academia in this industry in a sense that we don't take students. We welcome internship students, but they're kind of temporary. And we don't give them kind of degree, a doctoral degree or master's course degree, but we kind of collaborate with the students to do research together. But it's not like teaching, but rather kind of collaboration with students. From my perspective, AIST is kind of taking benefits of both sides of academic job and industry job, in a sense that I have a permanent position like an academic job because it's a nationally funded research organization. I can do research forever, or not forever, but as long as I want. And then I can also make a direct impact to the society throughout our research, tech transfer, or developing the software to be used by the creators or programmers by ourselves. AIST is in between academia and industry, whereas Arch is on the industry side. So Arch is Japanese animation production company. It's a Japanese animation production company, and Arch Research is a small team in Arch with interdisciplinary researchers, me as a computer scientist and Ryotaro Mihara as cultural anthropologist. And we are doing research on animation production support, or kind of studying how anime is being made in the industry. In many cases, research and development team in companies need to focus more on the projects that will make benefits in the future to the company. But at this moment, we can focus on what's really interesting about animation production. What I do in this research institute is I, of course, do research, but I also work on the actual development, like helping companies run events with research and development outcome. I also do development that directly benefits creators. This is the actual interface that I made for musicians. You can choose from the available songs, but also you can search for online song, or you can even upload a new song. But here I just choose one song from the predefined list. And as you see, there is this playback button. And if you hit the play button, I think the music is not streamed to your side. Suppose there is a music here. And if you go here to the position where the lyrics are being vocalized, you see these lyrics being animated. And you can switch between many kinds of different animations. You can also kind of, tweak the parameters to change the coloring. So it's really for novices, in a sense that you don't need to be an expert of the video authoring system, but you can just click, tap, and change the slider values or change the color palettes to see it really in a different style. And you can save it. You can, in some cases, you can do rendering to make this MP4 video file and upload it to YouTube or whatever you want. This is the sort of video authoring environment that I made for the creators. There were also this kind of professional looking interface that allows you to elaborate more on the video editing experiences. But I don't go further. But this is an example of the creativity support tool that I made with my current affiliation of AIST. It also has the user interface for programmers, where the programmers can define these kind of animation algorithms, and then you can see it live here. You can also change parameters here to see how the musicians or the end user can customize these algorithms. Everything is built into the single website called Text Alive. And it allows musicians, programmers, video authors, many kinds of creators to enjoy this kind of lyric videos. And this was done as part of my academic research. So of course, I'm a researcher. I like to publish papers. Yeah, you can read the paper if you want on my website. This is the actual web paper that I wrote for the system. But you notice that the screenshot looks really different from the current system, right? Because at the time of the paper being published, the system was a kind of prototype. But then I spent some more time to make that a bit more professional looking website. So, this is a desktop application at the time of the paper writing. But then I continued this research and development and finally made it available to the general public as a web service. So this is one example of a kind of successful project at AIST. And actually, interestingly, the system is used in many kinds of events nowadays in the virtual reality context, which was really surprising to me because in the beginning, I was thinking of making it available for the music live performances. If you look for these things, Yeah, like this one. This is a YouTube video. This is a character singing, and then you see that the lyric video is above her, like here. This is something that I was expecting, which was our system being used to author videos for the actual live performances. But then these days, there are many people using it for these kind of virtual reality performances as part of the virtual reality performances. As you can notice, these lyric texts are being animated by our system. Text Alive has been under active development for more than 9 years, I think, or about 9 years. It started in 2014 and it's still continuing. So these days, we shifted a focus from lyric videos to something that we named lyric apps. So I think you have seen lyric videos that I have demonstrated, right? If you enjoy music videos on YouTube, you see many videos coming with lyric text animating in synchrony with the music. But what we thought is, okay, so we enabled authoring lyric videos for musicians or motion graphic designers, and allow them to publish it at video sharing web services. But actually, one significant limitation of lyric video is that it's a kind of static media. So lyric video audiences can enjoy the content, but it's always the same. And my expertise is really in programming. So how about making these lyric-based art media interactive? How can we turn it into a kind of novel interactive media? That's something that we did after developing the textile website. And there was this programming contest held as part of the kind of larger exhibition called Hatsunemiku Magical Mirai, which is a kind of creative conference dedicated to this character named Hatsunemiku. She's really famous. So this is a programming contest website, not only in Japanese, but also in English. And it says color the creative culture through programming. And there are many programmers who are interested in getting involved in the creative culture through making these kind of creative applications. So if you hit the play button, it shows this kind of immersive 3D space. And when the lyrics are being vocalized, it shows these kind of animations, but it's not kind of static media. You can click on these kind of lyric text, which turns into this group of fish. And then when you click a sufficient amount of fishes, I think there will be something happening in this application. Like, there were kind of special animation effect, or let's see. Yeah, there were flowers growing up from the ground. And then, oh yeah, there is this big, it's not fish, how it's called, manta in Japanese, but these kind of things. It's all about the interactive experience. And every time you listen to music, you can enjoy a different perspective, different scenery generated by your actions, right? So it's really about making this novel kind of media format with help of our technologies that allows programmers to make this kind of novel artistic expressions. This explains my work at AIST pretty much. I really like to help these kind of diverse kinds of creators in the wild. This summer, I published kind of article for students. So this is a magazine called ACM Crossroads, the ACM magazine for students. ACM stands for Association for Computing Machinery, which is the largest computer science related academic community in the world. And it publishes this, I think, twice a year. This is a summer edition, but there was also winter edition, I think. And then in this summer edition 2023, they featured computer-aided media. And you notice that, something that I demonstrated is really about computer-aided media, right? So I wrote an article here, which is titled on the relationship between HCA researchers and creators, or how I became a toolsmith. So if you have time, I would really strongly suggest to read it, because it's an open access article available on the web. And what I discussed here is, computer science is really a fast-paced research domain. People publish papers on a daily basis, not an annual basis, but daily basis. And there are many kinds of cool work happening every day. And, there is a tendency for researchers to publish papers in a fast-paced manner, like every half year or something. But what I really think is important for us as an HCA researcher is to think of what artists are doing in the wild, rather than treating it as kind of research materials, but rather getting involved in the artistic practice, go into the wild and build a kind of personal relationship with artists, creators, programmers. For those who are interested in the field of HCI or becoming an HCA researcher, I would really encourage students to be interested in something in the wild, apart from the computer science, because it's all about building a better relationship between computers and human beings. So, computer side, you will learn it at some point. You will be forced to. You will learn how to code. You will learn how to do user study. But this, human part, I see many successful researchers having a lot of interest in this kind of, broad scope of human beings' activities alongside computers. So it's really important for students to get interested in broad area of activities. I would personally encourage people to get interest in kind of cultural activities, because it's exciting. Like, okay, in Japan, there are many Buddhist statues or temples, all those kind of things, but how we can connect these things with the computer-aided technologies. If we want to do something about HCI, well, actually, virtually, you can do anything. That's most exciting part of our research field, because there are so many people interested in so diverse topics, and it's really interesting to listen to those people doing weird stuff. Well, that something that look weird to me, but what I do look weird to them, and we enjoy it as an academic scholar. So, yeah, be interested in as many topics as you want. In a broader sense, computer science related skills like programming helps. And also, in particular in HCI, design skill is appreciated. Like designing a beautiful user interface requires design skills. I would say being a nice person is also important, in a sense that it's so for me, it's all about making tools for people. So it's better to be nice to people, to build a nice, good relationship with the creators or people who can benefit from the systems. One limitation that I see in the current field of human-computer interaction is that it's heavily biased in some sense. Meaning that there is a terminology called weirdness in our field, and weird stands for Western, educated, industrialized, rich, and democratic. Computer science, in general, when we come up with the companies who are really big in the field. We come up with the companies like Microsoft, Adobe, Amazon, Facebook, I don't know, Meta. Um, Everything is US based, or in some cases, Europe based. Not so many Japan based companies, unfortunately. And so it's the same for the researcher community, actually. Many kind of research is led by the Western culture of the community. And I think it's really important to think of the diversity of the academic field. There are many excellent Japan-based or Asia-based researchers, of course, and they publish many papers. But as a kind of field that involves humanities, I think it's really important to think of the diversity of the perspectives. So I can give you one single example, which is about helping anime creators. So let's say I want to do research that might help Pixar animators, right? I can publish paper at SIGGRAPH, which is a prestigious computer graphics conference, without explaining what Pixar is. But if I want to write a paper that helps Japanese animation production process, because the process is unknown in the community, I need to spend the introduction to explain how it looks like and how these animations are being made. And this kind of introduction already kind of consumes a lot of spaces in the paper, which actually provide a kind of significant effect on how the paper can be accepted or rejected. So it's really important to think of these kind of cultural differences and also incorporating these kind of practices in the world into this academic field. And then we can think of the better relationship between humans and computers in a global scale. So yeah, just kind of, being in the international community, getting involved in the community building and doing research for long-term goal I think it's really important and something that I want to work on and something that I want to see in the near future in our field.